Welcome back to Element 14 Presents. I'm Clem and we're close to the dark age of technology, and we need a beacon of light to guide us through the warp. But sadly, these kits don't come with lights in them, so we're gonna change that. We are building a freely programmable custom lighting controller for models. I'm using a Warhammer 40k model because frankly I've never built one of these in my life and this was the perfect excuse to get one. Of course this will work with all kinds of models, be them bought kits or 3D printed ones or scratch built. So I hope this is of use for many of you. You can get a big variety of model lighting controllers for RC models, for example. But they're usually very restricted in what they can actually do, like they have one or two lighting effects or they're made for a special purpose, like the specific lights on boats or planes. So I want to build a completely freely programmable one. We're using an ESP32 S2, mostly because I have them around and they are super cheap and more than capable. And I'm using really tiny LEDs so I can integrate them seamlessly into the model, and you couldn't tell when they're not on that they are even in there. So I want this model to be like fully playable as it would be in its original state, but if I plug it in, it actually lights up. My first step in reality was that I just draw up a lighting controller in KiCad and send that into fabrication. But for your pleasure, let's pretend that I actually got the model kit before and planned how to integrate it, because by a sheer coincidence, and this truly is just a coincidence, my final PCB perfectly to the 10th of the millimeter fits an already existing cavity in the 40k Rhino. So you can't see any modifications from the outside, and even the inside is still as usable as it was like without any of the modifications. So that's just a coincidence, but pretend like I'm a genius and I know all these things and did it in the right order. But first we have to make a plan for our sub-assembly so we can actually build and paint the model without getting ourselves cornered in. So with the help of the assembly instructions and some clever thinking, or not so clever thinking in this case, I was able to break down the model into sub-assemblies that would allow me to modify them individually, paint them individually, and then when I'm ready to integrate my electronics, I can assemble them in a way that allows me to integrate them seamlessly. Because if you assemble stuff too early and without a plan, there is a very little chance they can actually integrate an LED right in here and fit a cable through the middle when it's already glued together. So don't do that maybe. Jimmy Space and his Marines gave me the power to assemble the model without too much glue. That means some of the sub-assemblies I need then to remove again after painting for integrating my electronics controller into them. Don't even have to be glued. I planned on using magnets, but it turns out it doesn't even need magnets. Friction fit is good enough, so I can basically, if something goes wrong, I can get in there, rewire stuff, and for the programming I can use an access port from the back that is already built into the model. I just had to cut it open, basically. Yeah, I have identified and drilled holes in very specific places. The places are the lamps that I could see. So if this looks like something that would light up in reality, I drilled a hole through it and integrated an 0603 LED. I also bought some 0402 just in case, but it turns out 0603 is plenty small enough. And you can, if you want to avoid pesky soldering really tiny components to little wires, you can buy SMD LEDs already with wires on them. It has a bit of a markup, but it might be worth it for your modeling journey or your ease of mind. The custom paint job is kind of hard to explain. There are a lot of chapters in 40k and you can have like a lot of color schemes and make up your own. And I thought long about this, and I'm sure that I will probably not build up an army. It's just too expensive for me and I have nobody to play with. But I would like to paint this in like Element 14 color scheme. Basically, I even added a 14 so it's a bit more obvious. Up onto the electronics. How many channels of lighting should I control with it? Maybe 20. But let's remove 2 and never speak of those again. And then some of them should not be like very visible or something. I make 3 of them really special and give them the ability to also drive zeros if I ever need to use this board for any other project. Or you might want to add this functionality to the Razorback variant of the Rhino. Should work for that. Yeah. Welcome to KaiCat. This time the schematic is rather simple. We have a microcontroller over here. I'm using an ESP32S2 Room. As you can see, this is the NRND version, which means this is the old version that's no longer manufactured, but you still can buy them. I'm just using up parts, basically. Over here we have an interesting arrangement. We have a lot of resistors to 3.3 volts. We have this header here. This is where we connect all our LEDs, and these resistors are all limiting the current for each of these. I got the value by calculating it based on the 3.3 volts. 3.3 because this microcontroller runs on 3.3 volts. We have to regulate that, of course. So power comes in over a USB-C port. This is a full USB-C port here, just for USB 2.0, mind you. And this is then knocked down to 3.3 volts with a simple LDO, low dropout voltage regulator. We have 2 buttons, one for the boot mode, which means I'm put it in download mode if I reset it while this one is pushed. One to reset it, of course, mainly for ease of programming and stuff. But in the end, once this is programmed, I will only need to flash it once, and then it will automatically be flashable whenever I connect it with USB-C. This is pretty much it, apart from these 3 special connectors, which have the exact pinout needed to connect the servo. These 3 channels also, this is important in the selection of channels that I have there. They have to be PWM capable, so they should have their own ADC channels, so you can run them independently. Speaking of independently, because we have a lot of ADC channels on here, we can all use these independently for our lighting controls, which is set up in the programming. So I want to have like PWM all the things, sorry. I usually try to keep all SMD components on one side whenever I can for easier assembly, because double-sided SMD assembly is not so trivial. If you're new to soldering, you might want somebody to help you with that, or use THT components. In this case, I had size requirements that I didn't know at the time when I constructed the board, but I knew I wanted it to be as small as I can make it. So I've moved the ESP32S2 to the other side of the board. This is not a problem in this case, because I can SMD stencil assemble one side, and then I can just solder on the actual microcontroller package on the other side by hand. So I don't have problems with double reflow. Now this is the board view. As you can see, all these connectors are accessible from the outside. So this is all the stuff you're soldered to. And conveniently, it's also numbered in the same order as it is here on the board, which means this is pin 1, 2, 3, 4, blah, 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 blah. So we have 13 channels here and then 3 servo channels over here. And they are exactly in the order of numbers, and it's the numbers from 1 to 13. So it's really easy to solder something. It's like, okay, I know this thing that I soldered here is connected to pin 1. If I solder it here, it's 1, 2, 3, 4, it's pin 4. So that makes it rather easy. This is an external programming header, and for serial communication, just in case we need it for some more involved projects. And as you can see, all the parts are on one side, just the actual microcontroller is on the other side, so we can solder that on in a second step. Since all the sub-assembly parts are just press fit into there, I don't have to glue them. So that means if programming goes wrong, or I need to reset the microcontroller for whatever reason, or change the wiring after the fact, I just can. It's not that hard. Also, if you are programming an ESP32 S2 with the Arduino IDE, that means you can activate CDC on boot, which also means that you don't have to touch the boot button ever again if you want to reprogram it. You just have to plug it in. So this could be very handy once it is fully integrated in design, or in cases where you need to glue everything shut. Oh, we're already talking about programming. Well, this thing needs some programming, so I've attached the cable through the access port on the back. You can also use this upper portion here, is still removable, to get the cable in there if needed. And now we're programming this with the Arduino IDE, because this board is fully Arduino compatible, or this Rhino is fully Arduino compatible. For the first time in forever, I'm using something in the Arduino IDE that I haven't used before. It's this vector system library thingy. So I've created this sketch with the help of ChatGPT because I had no idea how to do this, and I didn't find a particularly useful tutorial for my task. But turns out it was quite helpful. It didn't make a compilable thing directly, but it is helping in like creating specific functions and stuff, and it shows me stuff that I didn't know, like this vector thing. So we have to define what a task is. So this is, imagine a multitasking system on your computer where you have more than one program open. Like at the moment I have the Arduino IDE open and the capture thing that captures my face, as you see. So these are two programs running independently on one Linux system in this case. We're running on a microcontroller, and we're also running multiple things at once, so we call that a task. And we have to define what a task is by making this structure. It's similar to a class, basically. So we have to give it all these things. These are basically what makes up the structure, and then we can use that structure later. So we say we need a vector that is made out of a task, and we call all vectors tasks. So if an object that is made up of a task, like here, that is called tasks. So now we can make functions that get a task. This is the type. It's like when you write int or long or byte or whatever, and then how it's called. So this is, we're making a new task, and this is whatever task is pumped into this function. And what this does is basically it has this milli stuff that's basically blinking without delay. If you look for a tutorial on that, you will see how that is done. Update brightness based on directions for fading up and down. So there's a direction variable that means does it go up or does it go down, which is -1 and 1. And what this does is basically we are writing one value after the other to the pin specified in the task and to the brightness specified in the task. And this task brightness will change with every cycle that we go through the whole loop, the loop that is running all the time on the Arduino. We do a very similar thing for blinking. The only difference is we just say high or low, and not updating the value all the time. So we only use digital white in that case. I didn't know this thing before, but it basically restricts to what that task state could be. In this case, we start at low, and it could change between high or low. So if we write something different here, it would do something different. But it's high or low just for a pin. Learned a few things. So then we have a function that creates a task. It takes in the pin, the speed, and the type of the function. The type means blinking, fading, and I think I also have like on or off. Yeah? But it's just done for blinking and fading in this example. We take that in, and then it creates a new task. And the new task takes in all these arguments and will set up the pin. And then basically that task is existent. So it's like opening a program on your computer. And then in the setup, we get a random seed. So we have this act of randomness where it just analog read from some pin that could be in various states, and the more electrical noise that might get into that, the more varied these seeds would be. If we tie this pin just to ground, then the randomness will be very low. If it acts like an antenna and can take up all kinds of random noises, electrical noise that is, then it will be a bigger variance. So we can also change the pin, of course. This is an example. If you want to create a task, then you basically say, I want this pin and I want this delay function in here. So for the speed of the function, and I want it to be this type of thing. So 0 is, I think, blinking, no, it's fading, and 1 is blinking. So we could just create tasks on our own. But what I want to do is give it some variety. So what we do is, this is the function that actually does execute all the things. So if there is a task, that means we first check which type it is, and then we use these handle functions to actually execute what is prescribed in the functions that we looked up earlier. And this here is what gives us these random functions. So every time it goes through the loop, there is a random chance for it to make up a new task or change an existing task. So I've limited this to the channels that are actually connected now, which means 1 to 7, which is actually pins 1 through 6, because there are just 6 channels in there. We just need +1 because it's C. And same goes for the speed, from 10 milliseconds to 1 second and 1 millisecond. That's the one here, also because it's C. And the type 0 to 2 because it's 0 or 1. And we need another one, the null terminator for C. So it's 0 to 2. And if that chance is done, originally it was a 5% chance, but I changed it to 25 because you couldn't really tell that there was a new task. The chance was so little. So I upped it a bit so you can actually see that something is happening that's changing with time. And then it creates a task, uses this random pin, random speed, random type, and just does it. And in the next loop, it will get handled. And so this is what it does all the time. So there is no, I go into a function, do it, go out of the function. No. In this case, it's, I go into the loop. There are tasks to be done. I look up the task. I do this one iteration of that. Look up the next one, do this one iteration of it, go through all the stuff in the loop, and then I do the next iteration. So basically all these things, they don't run actually really parallel. They run very shortly after each other, but only one loop for each task. No task is completed before the other one starts. We do each step one after the other, but in the big scheme of things, we're doing them all at the same time. It's a different way of programming. Some would call this object-orientated. I call it weird. With an RC model, it's clear that, hey, I'm driving it, so I'm controlling the lights and everything. But if it's a standing model on there, it's on its own. I'm not controlling it, so it should have like its own liveliness to its features. So all the lights should not just have a set pattern or have like some pre-programmed sequence. I would like to have some act of randomness, like it's acting on its own. And so in the programming, we have created a task system for adding random tasks, which means every time I plug this in, it will have a different lighting pattern. And while it's running, it constantly changes these based on a percentage of chance. So there's no control. For me, it's basically doing it on its own, so it always gives a new look, and I don't have to make these decisions. I think it's more realistic in that case, especially if you like consider different programming variants where it's fading, blinking stuff. You may want to restrict it to specific LEDs on your model. But yeah, this kind of randomness gives it a bit more like a realistic touch. At least that's my opinion. Korn does not care from where the blood flows, only that it flows. But the files for this project, including the code and the PCB and everything, that's available on the Element 14 community for free. So you can download that, make your own version. It's a bit of a more advanced soldering task, but the programming is quite simple if you just use the template and alter the functions to your needs. So I hope you have a lot of fun with that and light up many models. Building and painting this little 40K Rhino was quite a lot of fun, and integrating electronics into it, that brought it to the next level for me. I'm probably not gonna build a full army, but I'm gonna get a shovel and I have to go because there's another project waiting for me.